Okay, so we've got this function here, has domain x less than or equal to -1 and is defined by f of x equals x plus 1 all squared minus 2. So find the range. Okay, so we need to think about what's going on with this graph here. It is a quadratic graph. Okay, we can actually draw it because if you think about it, you know the standard graph for y equals x squared, isn't it? It's a smiley face like that, and it goes through the origin, doesn't it? That's y equals x squared. Okay. Now, if you've then, you can see how this then is maybe transformed because it's got then x plus 1 all squared. So you see we're adding 1 to x in that bracket. But remember, everything that happens in the bracket, you do the opposite. So, you know, if we were to transform this graph to get y equals x plus 1 all squared, you would shift that then, because it's positive 1, you shift it to minus direction, -1, so we'd end up there. So that's y equals x plus 1 all squared. Okay, and then of course you've got to take away 2, so then this will get shifted down 2. Right, so essentially this will be your graph. They're not asking us to sketch it, but I thought I'd do it anyway. Okay, so you're shifting this then down 2, so you end up down here. Okay, minimum is at -1. Shift it down 2 there. Now it says it has domain x is less than or equal to -1. So there's -1, so we go in that way basically, less than -1. And you could see at -1, -2 is your lowest, infinity is your highest. So straight away we've got the answer for the range here, -2, which is included, and infinity that is closed. Now that's one way of doing it. Of course, the other way of doing it is just to chuck -1 in there. Okay. Chuck -1 in there, and of course that comes out to be -2, which is what we wanted. And then because it's going all the way to negative infinity, put that in there. And of course negative infinity, but you're squaring it, so it makes it positive, so it'll tend to infinity. So you can see that 2 ways of getting the range. Okay, part B then, find an expression for f to the -1 of x, state the domain and range. Okay, so if we've got y equals x plus 1 all squared, take away 2, y plus 2 will be x plus 1 all squared, alright? And then take the square over, yeah, and square root, and when we square root we've got this. Now we must determine then whether to take a positive or negative. What I would do actually, I would leave it like this and look at what we've got for the domain. Now remember the domain was this, okay, right? Now that's interesting, because if you've got that, okay, x is less than or equal to -1, watch what happens if I'm quite clever here with this. If I take that -1 over, I'll have x plus 1, won't it? Is less than or equal to 0. Well, look what we've got here. We've got x plus 1, haven't we? And they're saying that it's less than or equal to 0. It's negative, in other words. So we could say, look, take negative root because domain, okay, is less than or equal to 1. So we'd say that, I mean, the domain of f, okay, is negative. Okay, and as we've just proven it there, haven't we? Okay, in fact, x plus 1 is negative. So therefore, negative y plus 2 equals x plus 1. So negative y plus 2 take away 1 equals x. So therefore f to the -1 of x equals negative root x plus 2 take away 1. Okay, and we've got our answer. Then it's asked for this domain and range. Of course, the domain is simply the range that we had in part A, and the range is simply the domain. And we know the domain is that, so we put minus infinity first, right? So let me scrap this now because you can't get to minus infinity. You're a round bracket on it. So minus infinity all the way up then to -1, which is included. But you need to get this the right order, okay? If I'd have written -1 first, it would have been wrong. You need to get the lowest number first to the highest. And it's job done.